Hi, in this video we are going to be doing lecture 3.3, and this is graphing linear functions. Okay, so we already know how to graph linear equations. We're just going to go into a little bit more detail now that we've introduced what functions are and function notation. But first, remember that we know by the vertical line test all linear equations except those that are vertical lines are also functions. Okay. So remember, if we were going to graph an equation, let's say y equals 2x, the first thing we would do is make a t-chart. We're going to pick numbers for x, we're going to plug them in, and we're going to evaluate and see what y gives us. So for this equation, I'm going to use -1, 0, and 1. Okay. So 2 times -1 is -2. 2 times 0 is 0. And 2 times 1 is 1. Okay. So these are my ordered pairs that I would use to graph. I'm going through the origin. Okay. Suppose we wanted to graph y equals 2x plus 1. Okay, so we still have x and y. We'd still have a t-chart. I'm still going to pick -1, 0, and +1. Okay. So I have 2 times -1 plus 1. That equals -2 plus 1. That equals -1. Okay, so here I have the point -1, -1. If I let x be 0, I have 2 times 0 plus 1. That equals 0 plus 1, so I get plus 1. Plus 1. If I let x be 1, I have 2 times 1 plus 1, and that's 2 plus 1. That gives me 3. Okay. So let's look at the ordered pairs that we came up with. Here, for 2x, I came up with the y values -2, 0, 1. Now, the only thing different in this equation is that I have plus 1. So if I can find these points, to find these ones, all I really need to do to my y values is add 1. -2 plus 1 would be -1. 0 plus 1 would be 1. Then, I'm sorry, here I have 1. That is incorrect. 2 times 1 is 2. 2. Sorry about that. Here I have 2 plus 1, and that gives me 3. Okay, so we would call this a parent graph because we can find this graph based on what we know from this t-chart. If I can find this t-chart, all I have to do is now add 1, and I end up with similar values for this t-chart. Okay, so let's look at the graph of 2x. Okay. So here we have the graph 2x. You can see my points are labeled At the bottom I have -1, -2. Then I go through the origin 0, 0. And then I have another point at +1, +2. And this graph is going up left to right. Okay. So we just saw the t-chart for 2x plus 1, and based on what I said, if I were to add 1 to each of these values, each of these points should go up 1. I shouldn't be moving left or right on the x. My x values that I picked stayed the same, but I should be able to shift all three of these points up 1 value and get my new line. Okay, so this is the graph of 2x. Let's look at the graph of 2x plus 1. So here, I have the graph of 2x plus 1. I have my points labeled, and you can see that all of my points did shift up 1. Originally, I was at -1, -2, and now I'm at -1, -1. I was at the origin 0, 0, and now I'm at 0, 1. And then I was at 1, +2, and here I'm at 1, +3. Okay, so let's graph these on the same graph, and we can see what they look like better. Okay, so here are each of my lines. The line in purple is 2x. The line in green is 2x plus 1. And looking at them both on the same graph here, you can see that all I did was shift my entire line up 1. Okay, so that's going to become an important concept for us later on. Okay, so let me turn my camera back on. So in general, we did see the graph of 2x plus 1. Okay, I'm labeling these here because there is a document on Canvas that has these pictures of the graphs for you, so you don't have to try to sketch them out. You can download them, print them up, or see them whenever you need. Okay, and then we saw the comparison of 2x and 2x plus 1. Okay, so this is our first picture, this is our second picture, this is our third picture in that document. Okay, so in general, a linear function is a function written in the form f of x, remember we introduced that last time, equals mx plus b. Okay, so here m and b are real numbers. Okay, so m is the coefficient of x. Remember, a coefficient is any number multiplied to a variable. Okay, and b here is a constant. Okay, so for example, going through the homework by now, you have seen already that we use f of x to denote functions, but you could also see other letters instead of f. You could see h of x, you could see g of x. Those are three very common ones that we use, but really it could be anything. You could be looking at e of x. Okay, they all represent functions. We say f of x, h of x, g of x, e of x. but they don't actually have a different meaning. It's this letter with the variable of interest in parentheses. This is function notation. Okay, so it's very helpful to be able to differentiate between our equations when we're looking at multiple equations. So that's really why we'll be using this a lot. So let's say I have a function g of x equals 2x plus 1. Okay, so we just saw the graph of this. We didn't call it f of x, but g of x is still okay. So this has the form f of x equals mx plus b. Here m equals 2 and b equals 1. Okay, so these are important pieces of information that we're going to need to be identifying. Okay, we'll come and talk more about b here in a few minutes. We'll talk more about m in the next section. Okay, so another example. Suppose I had two equations, f of x equals negative 3x and g of x equals negative 3x minus 6. Okay, so if I wanted to graph these two lines, I could have a t-chart. X are still my inputs, they're still what I'm picking. I have two different equations, so now I have two different outputs, so I'm going to go ahead and draw it in one chart. So here's f of x, and here's g of x. And just so we recall, this is negative 3x, and this is negative 3x minus 6. Okay. So picking numbers to plug in for x, I'm going to pick negative 1, 0, and 1. Okay. So first, if I plug negative 1 in here to negative 3x, I have negative 1 times negative 3. That gives me positive 3. And remember, because this starts off with negative 3x and then I have minus 6, from the last example we saw that I should be able to subtract 6 from this y value to get this value for the other function. Okay, so 3 minus 6 is negative 3. If I let x be 0, plugging it in here, I have negative 3 times 0. That's still 0. And if this is 0, I just have to subtract 6, so I end up with minus 6. Here I have 1, and if I have negative 3 times 1, I have negative 3. And if this is negative 3 minus 6, I have minus 9. Okay. So just in case you need to see it written out, first I evaluate f of x, so negative 3 times negative 1, that gives me positive 3, and positive 3 minus 6 equals negative 3. Okay. So this is where this 3 is coming from, this is where this 3 is coming from. Okay. If I have negative 3 times 0, that equals 0, and 0 minus 6 equals minus 6. If I have negative 3 times 1, I have negative 3, and negative 3 minus 6 equals negative 9. Okay. So if I graph these, I should expect to see this line, and then this line is shifted 6 units down. Okay, because that's what this minus 6 is telling me. I'm minus 6 units below this line. Okay. So I'm going to turn off my camera and we're going to look at this graph. Here we go. So the purple line here, this is negative 3x. Okay, so here's my points, negative 1, 3, 0, 0, 1, and negative 3. The green line here, this is minus 3x minus 6. And you can see all I'm doing is taking this point and going down 6 spaces to this point. I'm taking this point and I'm going down 6 spaces for the next point. So I'm talking about the origin. From the origin, I'm shifting down 6 spaces. From my final point 1 and negative 3, if I subtract 6 from negative 3, I go straight down and I'm at the point 1, negative 9. Okay, so we're going to be talking about shifting graphs more throughout the semester. Okay, so we talked about intercepts previously. So if I want to graph by intercepts, all I have to do is find my intercepts. Remember, my intercepts are where my graph is crossing the x and the y axes. It could happen on both of them. It could only happen on one of them. It depends on the equation or the function that we're looking at. Okay, so all linear functions have the form f of x equals mx plus b. So b is called the y-intercept. Okay. So remember, when we were talking about the y-intercept, we had to plug in 0 for x and then solve for y. Okay. So if we let x equals 0, then mx equals 0, okay, and all we're left with is b. So in function notation, if we let f(x) be 0, we plug in 0 for x. So we have m times 0 plus b. That is the same as 0 plus b, which is the same as b. Okay. So if we can identify b, we have the ordered pair 0b as our y-intercept. Okay. So examples. Okay. F of x equals 1/2 x plus 3. Okay. Well, b here is 3. Okay. So that means the y-intercept is 0, 3. Okay, I didn't have to do any work for that. All I had to do was identify what b was. And I automatically have the point 0, 3 because of what happens here. If I plug in 0 for x, this whole term goes away, and all I'm left with is 3. And that's how we find an intercept. Okay. So, for example, we could have g of x is equal to negative 2.5 x minus 1.3. Okay, so here, b is negative 1.3. Don't forget the negative sign. Okay, so the y-intercept is 0, negative 1.3. Another one, we could have h of x is equal to 5x plus 2. And here b is positive 2. So that means the y-intercept is 0, 2. So let's say we want to find the intercepts and graph. Okay. So let's say we have 3x plus 4y equals negative 12. And remember, this is something that we called standard form. We have standard form when both of our variables are on the same side of our equation. Okay. So remember, for intercepts, to find the y-intercept, I let x be 0 and I solve. For the x-intercept, I let y be 0 and I solve. So for x, we let y equals 0. So that means we have 3x plus 4 times 0 equals negative 12. 4 times 0 is just 0, so now we have 3x equals negative 12. Now to get x by itself, I have to divide both sides by 3. So divided by 3 on both sides. This reduces to 1. And here x equals negative 4. Okay, so if x is negative 4 and I let y be 0, my x-intercept here is the point negative 4, 0. Okay, so we're deciding this okay, and so it has to be right here. We solve this, and since it's x, that goes in the x-coordinate location. For the y-intercept, we let x equals 0. So we're looking at 3 times 0 plus 4y equals negative 12. 3 times 0 is just 0, so we're looking at 4y equals negative 12. Then I get y by itself. I divide both sides by 4. So divided by 4, divided by 4. Okay, that gives me y equals negative 3. Okay, so for my y-intercept, I have the ordered pair, and I let x be 0, so here I have 0. And I solved for y equals negative 3, so that goes in the y component, negative 3. Okay. And then we plot both these points and connect with a straight line. So sometimes it's easier to graph by intercepts because we didn't actually have to do a t-chart. Okay, so let's look at this graph. Give me just a second. Here we go. So we ended up with the points negative 4, 0, and 0, negative 3. You can see them labeled on the graph, and all we had to do is connect them with a straight line, and there is our equation graphed. So let's look at another example. I'm not going to graph this example, but we were looking at one in standard form. So this is also in standard form. But we've been talking about function notation and functions. So how do we get from standard form to function notation? Okay, so to get into function notation, we solve for y. Okay, so we have 4x minus 5y equals negative 20. If I'm solving for y, that means I don't want my term with x on this side. So I'm going to subtract both sides by 4x minus 4x. Okay, this adds up to 0. So I'm looking at negative 5y equals minus 4x minus 20. Remember, it's pretty standard for us to put terms with variables before constants. Okay. Next, to solve for y, to finish solving for y, I have to divide everything by negative 5. Okay. So I'm going to divide by negative 5. I'm going to divide this term by negative 5. And I'm going to divide this term by negative 5. Okay. So here, this gives me 1, and I'm looking at y equals positive 4/5 x plus 20 divided by 5 is 4. They were both negative, so it turned positive here. These are both negative, so it turned positive here. Now, you could have had negative 5y equals negative 4x minus 20 and then divided the entire thing by negative 5. But that doesn't really help us find the notation f of x equals mx plus b. Okay. So if we divide each term individually by 5, then we do end up with something that looks more like function notation. Okay. So while this is valid, it's much better to divide each term individually. Now that I have something that looks more like function notation, we replace y with f of x. So we have y equals 4/5 x plus 4, and that becomes f of x equals 4/5 x plus 4. Okay. From here, I already have one of my intercepts. Okay. 4 is my y-intercept. So my y-intercept is the point 0, 4. For my x-intercept, we let y equals 0, and since f of x is y, we're going to say 0 equals 4/5 x plus 4. To solve for x, I need to subtract 4 from both sides. Minus 4, minus 4. Okay, that gives me 0, and I'm looking at negative 4 equals 4/5 x. And remember, I want x to be alone, so I need to multiply something here that is going to make this fraction reduce to 1. And if I multiply that here, I also have to multiply that here. Okay, and I know to make any fraction reduce to 1, I multiply it by its reciprocal. So I am doing 5/4 times negative 4 equals 5 over 4 times 4/5 x. Okay. Remember, the entire point of this is 5 divides by 5 and 4 divides by 4. So I'm looking at x equals, to multiply these two together, remember this is really negative 4 over 1. So I'm multiplying numerator to numerator and denominator to denominator. So I'm looking at negative 20 over 4. And negative 20 over 4 is the same thing as negative 5. So I'm looking at the point negative 5, 0. And so all I'd have to do is plot these 2 points and connect them with a straight line. A couple of more examples just so I can make sure you don't get caught up in the homework. If you're asked to graph, for example, f of x equals 5x, well, here I don't have plus b. I don't have anything being added to this. Okay, so I can think that f of x equals 5x plus 0. So I haven't changed anything. 5x is the same thing as 5x plus 0, but now I can see a b. Okay, this tells me that my intercept, my y-intercept, is 0, 0. And since this is the origin, if this is the y-intercept, it is also the x-intercept. Okay, and if you need to do the work, you'd be doing 0 equals 5x. That means 0 over 5 equals 5x over 5. And that gives us x equals 0. Okay. When this happens, you have to find a t-chart. You have to use other points to draw your line because you're intercepting the x and y axes in the same place. Okay, so you don't have another point to connect your straight line to. So here I'd go back to negative 1, 0, and 1. I already know 0 is going through 0. I just have to plug negative 1 in, so I've got 5 times negative 1. That gives me negative 5, negative 5. And then I'd have to plug in 1, so 5 times 1 is positive 5, positive 5. And now you have your 3 points in order to draw your straight line. If you're asked to graph something like x minus 3 equals 5, we need to finish solving this equation for x. That's the only variable we see, so we need it by itself. Okay, so for example, graph this equation. So I'm looking at x minus 3 equals 5. I need to add 3 to both sides. That gives me x is equal to 8. And remember, for x equals the number, let's say this is 8. For x equals the number, we have a vertical line at that number. Okay. You could make a t-chart for this. However, the only input you have is 8. Okay, because that's what x is equal to. I'm not being able to evaluate for another variable, so it doesn't matter what y is, x is always 8. So I could say this is negative 1, 0, and 1. Looking at my line, I do have the point 8, negative 1, I do have the point 8, 0, and I do have the point 8, 1. Okay, so it's still a valid t-chart. Just remember, you don't have a choice for your inputs when you're looking at x equals a number. Okay, that number is every single input, and it goes through every single output you can think of. And the same thing happens for y. If you're asked to graph y plus 2 equals 1, then we need to finish solving this equation for the variable. Okay, so graph, this is another example. So I have y plus 2 equals 1, so I'm going to subtract 2 from both sides, gives me 0, and I have y equals negative 1. That means on my graph here at negative 1, I have a horizontal line. Okay. Remember, horizontal lines are functions, vertical lines are not functions. Okay. So this is the end of lecture 3.3. There is a section 3.3 homework on Pearson. There's also a document on Canvas. That's the graphs of 3.3. That way you can download the images I showed you in the video. Okay? Thanks.